I'm actually responsible for all of our documentation around authoring management packs, and have been doing that for a number of years. If you've seen any of our content, authoring guide and that sort of thing, you've probably seen my name attached to those things. Actually, a little bit quiet in that area for the last couple of years as I moved on to some other things. Azure Automation I've been doing for the last few months has been my big project. But I'm actually just about to move over to OMS. So for those familiar with the new Operations Management Suite and its relationship to OpsMan and management packs, and starting to basically bring together the worlds of automation and monitoring and that sort of thing. It's something that I'm just starting to take on, so you'll start to see some content coming out from us on that. So hopefully that will be valuable, and as I say, kind of start to bring together this full kind of holistic set of management. But that is my email there, so I'd invite you, please contact me, questions, comments, content you don't have that you need, etc. I'm always available for that. So to give an idea of the resources that I have available, and some of them I'm sure if you've been doing MP authoring, you probably are familiar with some of these, but the MP authoring guide is really our main set of content for doing all authoring of management packs. That's been around since 2007. We updated for 2012. Mainly just to get dashboards in there was the primary reason for that, to the new features that came out in 2012. Alias, the fairly simple URL to get there, and my apologies, the Silent guys and I always kind of have that little name collision there with MP authors, so that's just not to be confused with the name of their authoring tool they're going to be showing later. Also not to be confused with that is the Twitter handle that I've been using for a while, which is MP Author. Certainly feel free to go ahead and follow that. I typically will put out, anytime I put out any new resources, add to trainings or anything like that, I'll put that a tweet out there, and as we start getting into OMS and start building up that level of content, that's where I'll be announcing what's available. Then the last thing that I've got that I've been working on over the last few months is this MP development training on Virtual Academy, and a fairly long URL there, my apologies for that, but if you just go to MS Virtual Academy and look up my name or Management Pack Operations Manager, you should locate that training fairly quickly. But that now, I believe, is 23 lessons. A little bit of a misnomer. I think they say on there that it's going to be 28 lessons. That was kind of an initial estimate that I had of how that thing was going to sort out, and I certainly have some more to add. We need a dashboard session, we need a Linux session, so I'm going to be adding some other lessons to that. I'm not positive it's going to come out to 28, but that now stands, I think it's something like 10 to 12 hours of total content, which pretty much top to bottom everything you need to know about authoring management packs, going off in Visual Studio tool that we'll be talking about later on. So what I did, though, in putting this session together, because we were talking about doing an MP best practices to kick off the day and kind of set up what everybody else is going to be talking about. And I know I'm looking at it's over 400 attendees, and I know from my experience over the years of doing these, it's typically quite a wide variety. I imagine there are several people quite new to management packs, starting to maybe dabble and you know, kind of do some custom work. Other people that have probably been doing it for a while and maybe jumping on and seeing if there's something new they can pick up. So to try to appeal to that kind of wide audience and to kick things off, what I did is I put together here, basically condensed about 12 hours of content into an hour. So all this is essentially comes from that training. And just kind of basically kind of a quick top to bottom overview of management packs, what they are, how we go about designing these things, what you can expect in you know, starting to do this kind of work. And if you've never done it or really just getting started, hopefully this will give you a good flavor as to how we approach these and what's involved in doing it. If you have been doing it a while, even if you've been through all 12 hours of my training, first off, my congratulations for doing that. I don't know how much fun I am to listen to. But even still, so much I find in the MP world that when you start getting into this, people will start to get really bogged down in the details and start thinking XML and detailed implementation, and sometimes forget why they're even doing this in the first place, and really put a lot of thought into what it is they're designing and building as opposed to the implementation of it. So hopefully this will kind of do a level set on that, and you know, like I say, provide some of that kind of information for you. And as I say, also you know, kind of set up everybody else talking throughout the day. So to start things off, the basic question of what is a management pack, right? And what's interesting is an MP can contain so many things, and we start to think of these things, big packages of XML and sealed MP and all these kind of technical terms. And when you really think about, though, the function of a management pack is it's really just a big set of logic that runs an OpsMan that provides the logic for monitoring an application or a service. And I'll probably use the term application a whole lot. Certainly when you think that, as you well know, it can be an application, it can be a service, it can be a piece of hardware. And so as I say that, just kind of think of that as an all-encompassing term. But when we look at an MP, there's really some very distinct areas we're looking at. First is something that we call a service model. Service model is what are we going to monitor? And we implement that in the MP through a set of classes, relationships, discoveries. And I'll talk about these a bit more in a moment. But essentially, this builds a model, essentially says, what is it that I'm going to monitor? Next, we have what we call a health model, which is, given that I know what it is I'm going to monitor, what kind of logic do I need in order to do that monitoring? We do this through monitors, rules, tasks. There's couple others. I guess I should put dependencies and recoveries up there as well. But this is all the logic that we're going to perform in order to measure the health of that application that I've modeled in my service model. And then finally we have a presentation. So basically I've collected all this information, I'm measuring health states, I'm collecting performance data, I'm collecting all this stuff. How am I going to consume it? How are my users going to consume it? How am I going to be notified when there's something wrong? How am I going to report back to the business on SLAs? How am I going to provide back to my application owners of, you know, how their particular application's performing, etc. We do that through views and dashboards in the console, and also through reports. And I think we've got a report session going on later. So let's basically jump into each of these. And what I kind of put this together is more in terms of how we do this design and what goes into doing these definitions. So first off, when we think about the service model, how do we go about designing one of these things? And this is really, I mean, a service model can be very simplistic. We may have a class or two. We may have a full-blown one. And really when we sit down and we're looking at an overall, we may be modeling this large distributed application, we may be modeling something fairly simple, but it's still the same basic set of questions that we're going to go through. First off, what are the different components of this application? So I say maybe I'm dealing with some distributed application, I've got a website, I've got a database, maybe I've got some components running in the cloud, I've got some components running on-premise, I could have some running in another data center. I have hardware components. I have all of these different components of this particular application that we need to look at some health for, that need some representation in our management pack. And then for each of those components, what are the properties that I need to know? Certainly we're not trying to be SCCM. We're not trying to do inventory here and get an exhaustive set of properties for everything. But at least we do want to look, what are the properties that I need to know in order to monitor this? So if I look at a database, for instance, I need to know the database name so I can identify it. I need to know its size of the database. Is it set to auto-grow? Where are the data files for this particular database? And so basically the properties that I need in order to properly do my monitoring. And once I know all of these different components that are going to represent my application, how are they related to one another? Right? So in some cases I have one component that may completely own another. So if I can't have a database unless I have a database engine, for example. Or I may have, as I say, I have a website that isn't going to operate properly unless this particular database is available. So I have some relationship between those that I want to realize. And so we really think of all these components and how they're related to one another. In addition to understanding what it is that I've got out there, how am I going to find it? right? So OpsMan is not a tool where I'm going to go through and every time I add some new component to the environment, add a new server into the mix, that I have to go click and add things in. We're expecting all this stuff to just be discovered automatically. But when we write the management pack, we need to provide that logic. So we need to say how we're going to find these different components and how we're going to determine each of the properties that we're going to populate. So when we think in terms of the implementation, we're looking at a set of classes, relationships, and discoveries. And this is really the first step that we go through when we're doing a design. Now what's interesting about class, and this I'm obviously keeping a very high level here. This, I think I've got 3 or 4 different lessons in the training on basically the whole concept of classes, base classes, and I'm sure there's a whole session on relationships and discoveries, so there's quite a bit. I'm getting a very, very high level here. And also, whenever I say the word class, you can also think of the word target, which was really just a friendlier name to put in the console. I think MP Author tool also uses the term target. They're absolutely the same thing in this context. But what's the beauty of this design in OpsMan, and really the power of this concept, is that a class can represent anything. It can represent a computer, it can represent a database, it can represent a piece of hardware, a network device. It can be an abstract concept such as an application. It really can represent absolutely anything. And what makes that so powerful when we get into the MP world is that now I can use these very different types of objects that I'm modeling together using the same context. So one simple example, I have a Windows computer and a Linux computer. They're monitored very differently. I discover them very differently. But as far as a management pack is concerned, one's a class called Windows Computer, one's a class called Linux Computer, and they each have a certain set of properties. And I can put them together in a view. I can make relationships between them. I can relate them off to this network device. It's a very, very different type of monitoring that goes on. But this is the power of basically building a model using these common sets of things such as classes and relationships to represent some very different types of objects. So to illustrate this, and the training that I have out there is based on week-long training that I've done over the years for various different customers and different countries and the whole bit. And that's all, of course, based on samples that we built up in the documentation. And there's a sample application that I follow through all that. And over the course of the 5 days, we basically build a service model and health model. We build this entire management pack for this basically dummy application. And what I want to do here is show, just kind of walk through very quickly the service model that we build, a set of classes and relationships. And this is some design work that we go through. It's basically a whiteboard session. And this same whiteboard session, pretty much any customer that I've done a management pack with over the years, this is a session that we have where we sit there with a whiteboard and just start drawing out little boxes to represent our classes and arrows to represent our relationships. It's going to go really cleanly for me here, but usually in one of those sessions there's a lot of erasing, there's a lot of, okay, wait, let's change this here. You know, there's a lot of logic that goes into this. But very quickly, the application that I have here, and you can download in the TechNet gallery. I've got this example out there, the whole full-blown management pack, how to put it in your environment, and you can certainly download all the labs from the training as well. But this actually came from a real customer several years ago. It was actually a retail customer where they had a fairly classic design, central data center where it hosted the central components for line of business application. And then they had a whole set of stores. I think, if I remember right, it's something like 1,000 retail locations where they in each of them they had a different one or more servers at the location, as well as a bunch of clients point of sale, where you know, as orders were taken, they go into there, send up to the store server, the store would push up to the central location where orders were queued up and then processed. And so the challenge is, of course, to build a model to represent this whole thing. So where you could start out is basically this simple set of classes. Look, the components I just said, I have a store server, I have a store client. And I go through the training that I have one component at the central location where it receives all these client requests, and then another service that actually does the processing of all the orders. And then we added in later on this Unix role, which is just an application server to do some batch processing, and that's completely made up. We just wanted to be able to provide some Unix examples in. But this set of classes that I have here, and I'm obviously not going into all the details, in the parentheses there, what we call a base class, and the training and in the documentation we obviously go into all that detail of what base classes are and all the implications of them. But I could just have this simple set of classes to represent this entire application. All the monitoring that I want to do, I could target right at those. I could tell if services are up and down. I can measure performance. I can say, are these orders being written correctly to this database? Are the queues healthy? All of that I can perform with this set of classes. But then when you start going through your requirements of what you want your management pack to do, things start to get a little bit more complex. If you came and said, look, all we need to do is, we have some error events that we're looking for, we need to fire alerts, then I basically would probably come up with a model even simpler than the one I'm showing there, maybe just a couple of classes. But when you start getting into a lot more requirements, that's when you start building out a model in order to support those requirements. So in this case, we said, each of those queues that are coming in, we maintain a separate queue for each of those stores. And so rather than just raise an alert and say, I have a problem in one of the queues, we'd like to measure their health separately. And so in order to measure health separately, I need a separate class to represent that object. So we created a class for the queues. Then we added the requirement and said, well, in addition to all this, I have a requirement to report back to the business. We have an SLA for availability of the entire application. So we said, well, let's add an application class in, and those are what we call containment relationships, and that just allows us to do health rollout. So if there's any problem out there at any of these different components within the application, we're going to roll up and show an unhealthy state for the application itself. That will allow us to track SLAs and the whole bit to report back to the business. If you've ever done a distributed application in the operations console, this is exactly what that is. Now, distributed application, of course, is very static. You have to add components into it as you add them into your environment. I have a blog entry out there that's been out there for several years on making that a bit more dynamic. I still get questions on that one. But when we start doing authoring outside of the ops console, now we can start to actually do these things a bit more dynamic. So this adds in, and you could say, okay, now this is a model that's taking shape a little bit better. But then we have the requirement to say, look, I'd like to report on the health separately. I've got this central location, then I've got all my stores out there. I have separate support teams that handle those. I'd like to track SLAs separate. I'd like to be able to give them each their own view, looking at only their set of alerts. So at that point, we add in a couple of other classes. Let's say let's create this central and stores class. We'll still do this total rollup to the full-fledged application, but now I can separate that out between my central data center and all my stores. Let's take that a step further, and why not show an SLA for each of the individual stores? Now I can have a store view that shows me the health at each store. I can very quickly see all my stores are green. Look, I have a red over at this store, and drill down into which server or client is having that problem. Then if we take that out a little further, we say, well, this application talks to a database. This application won't be healthy unless that database is healthy. Database has already been discovered. It's being monitored by the SQL management pack, fully being managed in that way. I don't have to add any monitoring, but I do want to include it in my application. I do need to build a relationship so that when that database has a problem, I can show a problem to those administrators handling my central location. I can report back on my SLAs. And then to break it out a little further even, we have some websites that are in that central location that are being discovered by the IS management pack. Let's go ahead and include those in. So again, I realize this is a really fast overview for just this particular application, but the point that I really want to make here and that I really try to drive home as we walk through this, and as I say, this is probably an hour-long whiteboard session that we do in the training, and I walk through this entire thing in the Virtual Academy training, where I go through this entire thing. We actually build all this out, build the discoveries and the whole bit. But really the point here is this model not only supports the monitoring, but it basically gives me this particular functionality that we're defining. Give me a different set of requirements, and I'm going to come up with a very different model. The real point to keep in mind when you're building a set of classes, when you're building this model to represent your application, there is no right and wrong answer. Very often people will hand me and say, what model would you build for this? I don't know. I need to understand what kind of behavior you want. Tell me a behavior you want, then I can tell you the model that's going to best represent that. Okay, so that's really the point to go into that. And as I say, really trying to drive home this concept that we're building a model that's going to represent the application. So once you have this model, though, then we have to start worrying about discoveries. Now, discoveries, essentially you're going to have at least one discovery for every one of those classes. There are some exceptions to that I won't go into here, but that's talked quite a bit in the training about. But if I'm not going to discover a class, then the class is basically useless. I can create a management pack that just has these classes and relationships built, they would get installed, and would just sit there and nothing would ever happen. Discovery is actually a running workflow that's going to go out and find all the instances of those classes. So when I define this thing, for instance, called store server, discovery is what's going to go out, run on all the agents, and figure out, is this particular agent that I'm running, is this a store server? What are its different properties? How do I discover this thing? So a discovery, there's really three parts to a discovery. First off is, where is the source of that information? Where can I get information that tells me, does an instance of this class exist, and what are the values of its different properties? Second off are the criteria for it. So I can get this information, say, from the registry. What criteria am I looking for? Am I looking for a particular value? Am I seeing if a key exists? Next is the target. In other words, what agent is this thing going to run on? So if we think of the different kinds of discoveries that we have, and there are more than I show here, but these are the common ones. The most common, our absolute favorite, is registry discovery. Windows tends to put a bunch of information in the registry that we can read, and it's very light, very quick, very efficient way to do discovery. If the information's in the registry, that's almost always going to be our first choice. WSMan is what we use when we're starting to get into Linux discoveries, and looking in a Linux box and seeing if classes exist and collecting properties. SNMP if I'm doing network devices. So I see a network device over there. Let me throw out an SNMP query, see what data comes back. I'll determine if it's a device of a particular type or different properties about it. And then of course we get into discovery scripts. And this, I'm sure I have a whole lesson in the training on doing discovery scripts, which basically is the full-blown, there I can do any of the complex logic I need to. Now, if you look at a typical application, you're going to come up with a combination of these. So to give a very basic concept, I use the SQL management pack a lot. I've got a couple of slides on it. The SQL NP it's just a good example. Everybody has it. It's one of the first management packs you install, and it's just really very easily represents a lot of concepts that we try to illustrate. So if you ever wonder why I always use a SQL NP as an example, that's why. But if we think of the way that we discover SQL, so you have OpsMan installed, you have agents running on all these Windows servers, on host machines, on virtual machines, all these agents running around. First question is SQL even installed here? And for that, we'll use a registry discovery, because that has to go broad, right? We have to go out to every single agent and say, is SQL here? We're not going to do that with a script. But a registry is very quick and simple, and I forget exactly how it does it, but typically we'll do something like say, does this registry key exist? Because I know this application, in this case SQL, installs this particular registry key, this particular key in the registry, so I know if that exists, SQL is here. Therefore, I now can create a class that says SQL is on this machine, right? I can start to go and interrogate the registry as well, look what is the name of the database engine and maybe some other properties. Once I have that class created, then I may follow on with other discoveries targeted directly at that class, in this case to say run a script to go out and collect all the databases on that particular database engine. That's not something that I'm going to go throw out wide to every agent in the environment, obviously. I'll take the overhead of a script on those boxes only where it's needed. So again, this is something, I think I've got multiple lessons out there on discovery. I definitely have a full-blown one on scripts. But this is the kind of logic that we'll go through once we have this service model, is to sit back and think, how are we going to go out and discover this stuff? So let me just do quick, just because I get tired of doing slides all the time, and just show this model here. So this is my ops console. Just looking at my little sample environment, I'm going to admit right up front that I think there's a little bit of a problem where my health rollup isn't totally working in my lab environment. So anyway, but the model still exists. So this actually is the management pack that I showed before, the stores application that we walked through in the whole lesson. This is a diagram view for it. And so you see this is my application class here. There's my central, there's my stores class over here. This is exactly the diagram that I showed on that previous slide. Down here, and maybe just, no, sorry, let me zoom out a little bit. There we go. And so we see I showed that queue class where here, those individual queues, I have 5 different queues for the different stores there. And notice, yes, this health should roll up. If you notice I have an error here, that error should roll up, and that the management pack I know is fine. It's ran the recorded training, it's all rolling up just fine. There's some problem going on in my environment. My apologies for that. But then you see over here, here's that stores class that I showed, and here are the individual stores. And then you see we have the store servers underneath that. So a couple of points to make here. First off, just showing the diagram view here that represents all these classes and relationships discoveries had to run to find all this stuff in my sample environment. And on the one hand, this is very interesting maybe to look at from a diagram view, but also you can think of from a Health Explorer of what this service model, what kind of functionality this provides. So I can actually go drill down here through here's my central location and the health of that, and you can see my different components out there that I can go sit here and drill down on, right? And if you think of the health rollup that goes into that, my ability to target SLA into these classes, you can see basically how functional this starts to become. But another point, you may look at this and say, well, I see over here you have your stores, which represent your store servers, and over here you have queues for each store. Wouldn't it make sense to put those together? I'd say sure, maybe that does make sense. If that were the case, you would come up with a different service model to represent that. Okay, so again, this is really driving, and I always make this point over and over, there is no right and wrong answer to a service model. Really the point is, what's the function? If your requirement was, I want those queues to live over with that store class, great. Then that's a different service model that you would come up with, possibly a different set of discoveries to go along with that. Okay? Let's switch back. So that's service model. Okay, and as I say, I think maybe the first set of 10 lessons or so in the training are all on basically what I just said, so a whole lot more detail on that is available. But now let's look at a health model. So once I have all this set of classes and relationships, how am I going to measure the health of that, which really is why we're here. I mean, everything, service model, discoveries, I can install that, we'll discover it, I'll build that pretty diagram that I just showed, but where we showed health state on all those, that would be missing, because all that comes from all the monitoring logic that we have to put in place. So the basic way that we walk through building a health model is, first off, we say for each of those classes that I define, how do I tell if they're healthy? What is the logic that I need to perform? We'll talk about this a little bit more in terms of how we do that, because that's really the big exercise that we go through. So in addition to validating itself, what other classes does it depend on? So for example, I said I have a web application, for instance, that has a database it has to rely on. So the website itself might be completely healthy, but that database is not, right? So I need to understand that it relies on the health of this other class. In addition to that, what other errors can we detect that don't necessarily look at health state? Think, for instance, maybe a backup didn't run. Everything's working just fine, application's working great, no SLA should be hit, but I still have something important, some error that I need to report back. Then in addition to that, what other data can we collect? What kind of performance data, event data, to just look at our ongoing operations so we can look at trends and just performance statistics? And then finally we think, what might an admin do with all this, right? How might they respond if we find an error in the environment? And so how those get implemented in the MP are through monitors, rules, and then discoveries, diagnostics, recoveries, and tasks. So we're going to talk more about monitors in a bit and the different types of monitors, and that really is the core of the health model, are defining your set of monitors and monitoring logic. Rules is how we basically fire an alert without setting health state. I'll talk about that a little bit more, and also how we do all that data collection. So what I'm not going to talk too much about, at least now, and we certainly have information out there, is on diagnostics, recoveries, and tasks. And I want to talk a bit about that one. Recoveries are something that we have documented on how to do them, and I usually kind of steer people away from them. And the reason I say that is you think the concept typically is great. If some problem occurs, I want to run an automated recovery and fix it without anybody getting involved. And the challenge that we run into is very often that's a whole lot easier said than done. Very often we need to do a lot more analysis, what problem's going on. Even something as simple as saying a service stopped, automatically restart it. What if the thing keeps stopping and restarting and stopping and restarting? That's not something that we can just automate. And so when you look at recoveries in an MP, they're fairly simple. Management packs are very, very good at doing hundreds and thousands of very, very simple workflows. They're one step, right? Collect an event. If you see this event, raise an alert. Collect this performance counter. Set health state if it crosses a threshold. These are really simple workflows. But when you think of an automated recovery, these are very complex. Very often we have to inspect multiple things. Let's try this. If that doesn't work, then let's try this over here. And at some point we're going to give up. We're going to tell an admin this can't automatically be fixed. We need somebody to get involved. That's not something that's going to be very easy to implement in a management pack. And so what we have done, I've certainly got some stuff out there in the TechNet gallery. I've done a session on MMS, is to integrate other automation tools. And so we've got some samples out there, for instance, on connecting Orchestrator. I believe Infront has some offerings around this as well. It's certainly something I've talked to their guys with about in the past. So that scenario is an alert gets raised. Let's kick off a runbook over an Orchestrator to go out and perform a very complex workflow and try to do an automated recovery. And certainly we're starting to think on the other automation tools such as SMA and Azure Automation to bring that in. And so I think that's probably more of the type of scenario we're going through. And as I mentioned before, as I'm taking on OMS and we're starting to bring together kind of the monitoring and automation technologies, I think that's an area we're going to be able to go into in a little more detail. So in any event, just that, I guess, a bit of a disclaimer there. But moving on here, so when we think of the monitoring requirements, and this is just a very high-level process to go through, because I find that the mistake that people tend to make when they're building a set of monitoring for a particular application is they tend to focus on what is available very easily as opposed to really looking at what are the requirements for this application. In other words, they'll look at, okay, what perf counters do I have? What events is this thing generating? And basically starting with what information is it giving me. But sometimes the information may not be that simple. And kind of the number one thing that I would say the number one thing that I worry about with management packs is that they do no harm. So in other words, a management pack is supposed to simply watch. The worst thing that can possibly happen is that the management pack actually causes a problem. But beyond that, assuming that we are doing our job of just watching, the main thing that I'm always worried about is that an application has a problem and we don't know about it. Somebody's not able to do it, or there's some degraded performance, or a customer's not able to perform some action they need to perform, and I'm looking at a whole bunch of green icons on my MP. So that's ultimately, and very often, these things cannot be detected just through some of this simple information. We may need to go out and get this information. So the process we typically want to go through is for each of those classes, define the different functions it needs to perform. Right? So in the example I showed there, I defined this class called a central receiver. So the central receiver's job is the service that runs, handles all these clients connecting in, accepts an order from them, writes it to a database. And so if you think of those distinct functions, receive information from the clients, write to the database. Then for each of those functions, what are the different problems that can occur? Maybe it doesn't have network connectivity. Clients can't get to it. It's not able to write to the database. And we try to list out what are all those different things that could go wrong. For each of those problems, how am I going to detect if that happens? Right? And maybe it's something simple. If it can't write to the database, it's going to throw an error. Great. That's fairly simple. What if it's missing network connectivity? Nobody can connect to it. That might not be something that the application is looking for. It might think it's running just fine. I might need to perform some other action, some remote connection into it periodically, for example, to make sure it's still listening. And so when you think that's the kind of process that we want to go through and really figure out, first off, not the easy stuff, but how am I going to tell all the functions this thing does, what might go wrong, and how might I detect that? Okay, and so when we think of a monitor, and this is what we're going to do, is we want to get a set of monitors that look for all this kind of information, right? And we are able to report on the health of the different functions that each of those classes performs. So this is basically the way that I think about a monitor. What we're looking there is basically a three-state monitor. And what's distinct about a monitor and what distinguishes it from a rule, I'll talk about rules a bit in a moment, but a rule may be something very simple. I see a problem, raise an alert. A monitor is required to provide logic for each of its health states. So in this case, I have a three-state monitor. It can be healthy, warning, or critical. Typically, warning and critical are easy. Some problem set to an error state. Success, ironically, is sometimes the difficult one to do. So for instance, this thing can't write to a database. Throw out an event that says it can't write to the database. Great, I'll take this monitor, I'll trigger an error state on it. But then database comes back online, application's now able to write. Is it going to give me a success event saying we're now good, so my monitor knows to flip back to a green state? If that's not the case, we might need to maybe do some script periodically that does that test. Or we might just simply say, look, I need an admin to go and verify that and manually turn that thing back to a green state. But again, this is really what distinguishes a monitor, is understanding that I'm required to define each of its health states. Now, the other thing you're going to worry about with mine is basically where's this data going to come from? And that really is usually the condition stuff in there, you know, the healthy and warning conditions. That's the easy part. The more challenging part often is where am I going to get this information from? Now, I separate this into what I call passive and active monitoring. And next slide, I'm going to talk about a lot more detail what I mean by that. Those are not terms you're going to see anywhere in a management pack. These are completely my terms in ways that I kind of view this stuff and think about. This actually has its history back in work we used to do with Mom 2005, for those of you who might be as old as me or remember those days. But if we think of the place that we typically get our data from for a monitor, some of the obvious ones, we have Windows events, we have performance counters setting against a threshold. We can go against text logs, which basically work like Windows events. Or look at the state of the service. When I'm dealing with a Linux machine, very often I'm looking at syslog. So these are very, let's say, standard, pretty easy to create workflows looking at all that information. You know, as I say, looking for error events, driving health state, etc. Then there's the more active monitoring we tend to do. Passive monitoring is really when I'm looking at the information is out there, I just need to go get it. I just need to basically listen for it and look at it. More active monitoring is when we're polling, we're doing something. So in my example, I have this receiver service that's sitting there. It's required to collect, basically taking connections from clients. Well, if it's not able to do that, it's not going to tell me, it's not going to give me an event, I need to create what we call a perspective, which says go externally out on some box and connect to this thing periodically. So you see what we call perspectives in, I believe we have a website monitor, we have a database monitor that's in the templates in the Ops console. And that allows you to basically go and test, connect to this website now and again and make sure it's responding, make sure that we see the performance we need to. Same thing if we don't have a standard one for you, then you may need to write a script, go connect to this thing periodically and do a test on it. Okay, and that's when you need to start doing more active monitoring. So let's take this concept a little bit further. And this is getting, this slide, and this I believe I have in the online training. And this is probably getting a little bit philosophical. Again, this is not so much actual details of the MP, but really how to approach this concept of building a health model. And it's something that I've shown at conferences and has been pretty popular, and people seem to get something out of it. So I thought it made sense to include here. So if you think, though, when you install OpsMan, and then you go out and you install this basically, you go out and get all the standard management packs. You install it in the Windows Server MP, you install the Azure MP, you install SQL, IS, etc. Maybe you have some from the hardware vendors for those host systems to look at hardware components. And you think of all the set of management packs that get installed. Without you doing anything really, you're getting a ton of monitoring already pre-built in all these management packs. So let's say I have an application, as I mentioned, I have a web application, has a database, these different components. Before I do anything, I have done no custom work at all. I'm getting a lot of monitoring going on. We're going to detect that IS is there. We're going to find your website. We're going to tell you if the website's online. We're going to find SQL Server, find your database, tell you if your database is healthy. All this stuff is already built in to all these management packs. The delta that you need to create is for your application. What are the other things? All this other stuff could be healthy, yet my application is having a problem. What are the things unique to my application, given that all these other components are healthy, that I need to look for? And that's basically the management pack that you're going to build. Now, if we think in terms of kind of the passive monitoring that's going on, these are mainly things like events and performance data, as I mentioned. And each of the individual management packs is going to generate these. So let's say I have processor running high. The operating system, I think the Windows MP is going to generate, hey, you have processor running high on this. If I have a problem with the database, the SQL MP is going to generate that. IS is going to generate a problem if we have a problem with the website. So each of the individual MPs are going to generate basically this information for us. The more active monitoring is typically when we're doing things like synthetic transactions. Look, I've got this application here, it's running, everything seems to be okay, but let's just do a periodic logon to the thing. I have an SLA that says the logon process needs to occur, say, within 1 second from the time the user says log in. And so I know there are all these different components that come into play for that one transaction. Let's go ahead and perform that every few minutes. And let's measure the total time that takes. That's instead of looking at an individual component, that's basically going right across the entire stack. All of those different components need to be working properly in order for that test to occur. So if you think in terms of what's unique about these two, is the passive monitoring, it's basically giving us clues. We're assuming no news is good news. As long as I don't see an error event, as long as my performance counters are within threshold, I assume everything's working right. But I'm really not guaranteed. I don't know that it's working right. That's what the synthetic transaction, that's what the more active monitoring is going to tell me. If I try to do a logon, that guarantees, yes, I know that logon occurred within 1 second. I know that login is working fine. I'm going to go and do, say, a product look up in the product database. That query returned the correct data. It returned it within threshold. I'm guaranteed that this is working right. However, if we look at that active monitoring, those transactions, while they guarantee me a good answer, they don't necessarily help me in determining root cause. The thing took 5 seconds. I don't know why. I just walked across, 10 different components. There are so many things that come into play that it's very difficult for that to identify the root cause. What is good at the root cause is a more passive monitoring, right? So hopefully if that's occurring, taking a long time to occur, I've got some performance counter that's off. Processors are running high. Maybe the database is responding slowly. That's where My passive monitoring hopefully is going to help to find that root cause. So if you think as we build this overall model of measuring health, it's a combination of these two that we're looking for. There's very often not just this one simple answer that's going to tell us it's something. It certainly goes far beyond just if I see this error event, raise an alert, which really takes us all the way back to the MOM 2000 days. So again, this is, as I say, there's nothing that you're going to see called active and passive in a management pack. It's not part of the authoring process, but as you get more into this design work and are really trying to build some good, robust monitoring for an application, I found that this is a good tool and some good concepts that we've had some success with over the years in really helping to approach to that monitoring. So in any event, kind of jumping off that back into the MPs themselves, and as I mentioned, I always use the SQL MP. But to really illustrate this concept that you know, we're looking across a lot of different types of monitoring going on in order to perform this work. This here is just a diagram, and I'm sure everybody has seen these. This is the Health Explorer, and I'm showing here a SQL database engine and then one of the databases on that engine. And some pretty interesting concepts that we can illustrate here. First off is showing what we call unit monitors. Now when I say the word monitor, I'm probably talking about a unit monitor. A unit monitor is one that does something, right? Look at a perf counter, see if it's threshold, see if I have an error event. All the things I've been saying, those are what we call unit monitors. And so if we look at this Health Explorer for SQL, okay, first off, let's see if the services are running. Okay, that goes into our overall availability. We've got perf counters we can look at. We've got events we're looking for, anywhere the log shipping occurs for a database. Fortunately, that gives us an error event and the corresponding success event that says things are working well again. We have scripts that we need to run. So seeing if, looking at configuration of the database engine, the individual databases, I have no other way of getting that information other than running a script periodically and going out and collecting it. And so obviously I could sit here and go through the whole thing, and it's actually, the SQL MP is a very good one to go look at and see all kind of the logic behind these different monitors that are running out there. But it really goes to show that there's just a variety of these different, and when you look at the individual classes, here's what I need to measure, where does that data live, and what operation do I need to perform in order to measure it. And so those are, as I say, the unit monitor. Then we have what we call dependency monitors. Now a dependency monitor is how we do health rollup, right? So as I said before, the health of this component relies on this other component. But we actually get more complex than that. So if you look over here, say at my database side, you can see one of the things we're looking at is the database files that this database lives on. So if the database file is not healthy, chances are the database is not going to be healthy. So we do a dependency monitor in order to do that health rollout. Basically anything that goes wrong with that database file, we're going to roll out. Then look over at the database engine side, and you can see this one here is my stores database, which is right here. But notice that it's only under the performance monitor. If you look up here under availability, you don't see databases under there. The logic that's being used here is basically, look, if a database is unavailable, I can simply take a database offline. It goes to a red state. Well, that doesn't mean my database is unhealthy. I've got all these other databases that are totally fine. The database engine itself is healthy. It's the individual database that's not. So in that case, I'm not going to roll up the health. The database engine is fine. Okay, we don't just automatically blindly roll up health all the time. But if we think of the performance, chances are if the database performance is off, that very well could represent some problem in the database engine or the system that it's running on. So that is the kind of health I want to roll out. So again, just illustrating that concept that these things certainly can get a lot more complex than just blindly this thing hosts this thing, therefore roll up the health on it. So again, something that we talk a lot more, that logic in the training we go into. Then we have aggregate monitors. Now everybody knows the four aggregates. You may just not know them by their name, which are availability, configuration, performance, and security. Every single class that you create is going to inherit those four. But we also can create our own. And so, and there are very distinct reasons to create your own aggregate monitors. And what those do is they basically consolidate other monitors. So the best example that I've heard of, and this one's fairly common, when you'll say, look, I've got these, say, 3 different monitors that are very distinct, they're very distinct sets of logic, and very distinct things that I'm measuring, but I really only want one alert between them. In other words, if one of those goes to red state, I want an alert. If the other one goes to red state, I don't want to get a second alert. We're already, we're already alerted to the problem. I have this ticketing system that, I get a new ticket every time an alert gets generated. Now you're giving me 2 tickets. I should only have 1. That's something that we can actually, a type of functionality we can do with an aggregate monitor. We say, look, let's take those 3 monitors. We'll put them under an aggregate. The aggregate will fire the alert. So if 1 goes bad, 2, all 3, we're still only going to get 1 alert. So again, not necessarily going too deep down into the functionality there, but that's exactly the kind of logic that we go through when we're trying to figure out measuring the health state, trying to figure out what kind of behavior that I want, and understanding all these different types of monitors and logic that are available to me in order to implement that type of logic. So then in addition to monitors are rules. Now basically monitors do one thing and one thing only, and that's set health state. That's the only thing the monitor does. Now, of course, there may be a whole lot of complexity that goes into setting that health state, but it still only performs one function. Rules basically do one of 3 things. Number 1 is generate an alert without setting health, and I already gave one example for that. Let's say my backup didn't run. So I may want an alert, hey, backup didn't run last night, or some function was performed. Everything's fine, everything is healthy, but there's something I need to be alerted to. That's when I want to bring in a rule. The other is doing all the data collection. So all the times when we're collecting events, we're collecting performance counters, all that work is happening with rules. The last is to execute some command or execute some script on a time basis. It's not something we do very often. Basically, then we're trying to turn OpsMan into a job scheduler. It's not very good at that. It wasn't designed for that. And so it's really a scenario we don't talk about too much. But when we think about rules, we tend to think about these, and this is kind of leading us into the last part of the discussion, but we basically think about them in this form, where a monitor, I think, where am I going to get the data from? What condition do I need for each health state? And then which health state I'm going to set. A rule, we think in terms of where's the data going to come from? And that is the exact, literally the identical set of data sources that go into monitors, and that could be looking for something, it could be doing something such as running a script. And how is this rule going to start? We then have some condition that may run, and first off, that may look to see if some events match. Look, the script got run, send some data out. The condition's going to look at it. Do we say healthy or not? What does this thing say? Is it an interesting event or not? Is it an interesting counter or not? And then the last is to actually do something. Generate an alert, save it to a database. Okay, so this is essentially the way that we look at a rule. Now, and as I say, that leads us into really the last part of the discussion here. And this is one, and especially in the audience we're going, looking today that's ahead of everybody here. It's really something I wanted to help to distinguish. So every single thing that I've talked about up until now, you can do with the MP Author tool that the Scilec guys mentioned earlier on that they're going to show in a bit. I'll show the Visual Studio in a couple of hours. Everything that I've talked about, creating your service model, creating your classes or targets, creating your discoveries, creating all this monitoring, all these rules, and the whole bit. All that can be done with that tool. So if you think about basically kind of the ways of doing authoring, most people will start in the operations console and go to the authoring node there and perform some. There's some decent functionality you can perform there. Then you probably realize the limits very quickly, and you move off to a tool like MP Author and all the rich, interesting new functionality that adds, and the wizard-driven and all this extra functionality you can't do in the operations console. But then there's a point, and as they mentioned, where you're going to hit some things that tool doesn't support. Now, we run into, at this point, the classic trade-off in computing, which is if I'm going to hide complexity from you, chances are I'm going to have to take away some flexibility. If I'm going to give you some extra flexibility, you're probably going to have to take on some extra complexity. And when it comes to the management pack world, there's a very distinct line that you're going to cross. And if you haven't seen these in a couple hours, they're going to show the MP Author tool. I'll show the Visual Studio tool. You're going to see there's a pretty healthy hurdle that you're going to go over in terms of that complexity. Basically, the MP Author tool is going to hide a lot of that complexity from you, keep you on a logical level. I want to create a rule that collects this performance counter and saves it to a database. I want to create a monitor that looks at that same performance counter, sample it every 15 minutes. Here's my warning threshold, my error threshold. Okay, and do you want to generate an alert or not? And it's going to be very logical in terms of the information that you're going to need to provide. When you want to start creating your own custom workflows, though, so basically the way that we give you that simplicity is by basically locking you in to certain sets of workflows. These are the different types of workflows you're going to get to create. They're a very common one. See an event, raise an alert, monitor a performance counter, run a script. So there's all of those very common scenarios, and we can give you nice UI around that. But then you hit the point where you say, now I want to create my own workflows. I want to start customizing my own stuff. In order to do that, I basically need to take off that simplicity layer and expose you down to the actual XML and all of the underlying components. That's the hurdle that you're going to cross. And I just want to give a little bit of an intro conceptually to it here, and I'll show it in Visual Studio in a couple of hours. But when I think workflow, when I think of a rule, you're going to think in terms right now probably of this fairly straightforward, like I said, see a performance counter or collect an event, doesn't match this criteria, go ahead and save it. This is the way, on the screen there, of how I think of a rule and what is actually happening under the covers. When you go into the Ops console, you go into MP Author and you create that, this is what's being generated. I'm thinking in terms of the modules that go into this workflow. So all workflows, discoveries, monitors, rules, diagnostics, everything that's running as an ops man is created from a set of building blocks that we call modules. A module is essentially a little black box of functionality. So we have modules that will collect an event, a module will collect a perf counter, a module that will run a script. We have modules that will look at incoming data and see if it matches a condition. We'll have a module that brings in data of one type, converts it to another type, another module that generates an alert, another module that saves the database. Hundreds and hundreds of these modules that are available through all the library management packs that you all have installed. Any new, whether you're installing SQL, IIS, all these other MPs are also bringing in their own modules. And again, think of these as building blocks that go into workflows. So when you start taking on this challenge of creating your own custom workflows, now basically you have access to this entire set of building blocks in order to create your own workflows and also to create your own modules. So to give just a very quick example here, to give a bit of a flavor for this, let's take a little bit more specific kind of rule that I might have. So let's say I have this rule that I just mentioned. Let's say I'm collecting an event. Okay, so an event collection rule is first off going to have a data source that goes out and collects the event. Every single time an event hits, let's say we're doing Windows events. I'm watching a Windows event log, and every single time an event hits that module is going to pick it up. It's going to send that data out as event data, and there's different types of data that we work with. We have event data, performance data, SNMP data, property bags, which is what comes out of a script. So it's going to, event hits the event log, this module picks it up, throws it out to the next module. Next module on this is what we call an expression filter. The expression filter is going to look at that incoming event data and sees if it matches a condition. I'm looking for an event that matches this particular source with this event number. If that doesn't match, I'm going to throw it away. If it does match, I'm going to let it come on through. The last module there is a collect event module. That simply says, give me event data, I'll go ahead and collect it. Now things obviously can get a lot more complex than this. Maybe the event, that first module, maybe that's running a script. And so in that case, it would be outputting a type of data we call a property bag. So in that case, my expression there would need to do a conversion for me. I have another module that will accept a property bag, and it will convert it to event data, which is what that last module is looking for. Okay, and so that's the type of level that we'll start working at. Now let's take, here's a specific example that I built before, is let's say I have an application and we want to collect event data like this, but this thing's not logging to the event log, it's logging to a database. So it's instead of writing an event, it's writing a record into a database table that represents essentially the functional equivalent of an event. In that case, this wouldn't work, because I say, well, that event module that I have there, that looks at Windows events. This thing lives out in a database. In that case, I could create myself a custom module, and I could say, let's take another couple of modules. I have another one out there that'll run a time script. I'll take a PowerShell script, I'll connect to this database, and I'll pick up the records out of there. And I'll send those out in a property bag, which is just the output data type for a monitoring script. I'll then take another module, it's a data mapper module. It'll take that property bag, it'll convert it to event data. And I'll take those two modules, and I'm going to wrap them up inside another module. And they'll expose that as event data. Now what's nice is once you've built that, you've now built essentially a new little black box that simply knows I go out to this database and I send out event data. As an author, you don't know how it does that, you don't care why it does that, all you know is you now have that available to you. And I can now put it in as part of my workflow. So this is, and again, this is way high level. This is the type of logic we go through, though. When we start to get into custom workflows, this is the type of, we're doing whiteboards with lots of boxes and arrows and boxes within other boxes. We'll get into, let's wrap this module inside of another module. We'll take that, we'll add another, and wrap those up inside a module. And you get into this kind of work. All this is implemented in XML. So this is kind of the high-level conceptual. In a couple of hours when I show Visual Studio, I'll actually go down to the XML and show you kind of what this looks like. I mean, I'll give some intro to the tool and also kind of expose the level that you're working at. As I say, when should you take on that level of complexity? And really my goal in doing that is really helping you understand, number one, do you even have the requirement to do that? I would never have it, don't bother taking on this set of complexity if you don't have the requirements to do so. But if there are those requirements, to really help you understand, okay, as far as my skill set, we're getting in XML, we're getting kind of some developer concepts here. Is that something that my skill set that I feel comfortable doing? So hopefully this gives a high-level flavor to it, and in a couple hours, as I say, I'll give a little bit more to give you a good flavor for that. So that's what I had here. There's a survey link there for this session. As I say, this is a very quick blast-through overview of probably about 12 hours of content. I'm guessing on that. It's maybe a little more, maybe a little less out there on Virtual Academy. I gave my email at the start, so feel free if you've been through the training, if you have questions on this, you say, hey, I really need you to give me a lesson on this or that. I'm still recording those things and really trying to go off what people are missing and, taking requests as I can get them. So I think I've even left a little bit more than 5 minutes, I think, on time. So certainly if there are any questions, I
unmuted.
Throw those out.
Hi, Brian. Thank you. That was fantastic. I'm sure everyone got a lot out of it, and we look forward to hearing you again this afternoon. I'm hoping everyone will answer or complete the survey. Your feedback is appreciated. Getting some good comments in the chat box about your presentation, Brian. Thank you very much. I've got some questions. Some were already answered throughout the session. Here's one from Frank. He asks, why isn't there a module that allows us to extract the substring of a previous data item?
Extract this? Yeah. No, there isn't, is there? Well, so back up. So first off, the question why there isn't. Honestly, in my experience, I can't necessarily answer why they didn't build one because I'm not part of the engineering team. Maybe somebody there could answer that. My guess is it's probably one that was on the board and just didn't get implemented. But there really are an infinite number of those that you'll come up with. In that case, typically what we'll do, and I'm going to guess that you already figured this out, is you'd probably have to run a little script that would accept, create a module that accepts some data in, runs a script, and then outputs whatever based on that substring. So I mean, send me an email if you're like challenged with some scenario that you can't get built. I can help you do it. So it would be a nice module. It's a request I've heard before. It's a request I've had, quite honestly.
Thank you, Brian. Frank, hopefully that answered your question, but as Brian said, you can definitely email him for more information. Looking at another one here, Brian, has anyone ever developed templates to get information from the customer about the monitoring alerting that they need? That's from Steven.
Yeah, kinda. I actually have something, and it's been out there for a while, and so I'm going to admit that I don't remember the exact details of it, but I do believe I've got something out there, like a sample specification. I think I called it out on the TechNet Gallery. If you just search my name on the TechNet Gallery, you'll get, I don't know, 20, 30 hits. But we did, if there's not a template in there or not something you're looking for, you can send me a mail. I do have something that I used years ago, which is basically like that. I mean, I worked with a customer where we wanted to go out to the individual teams and say, look, here, fill this out, and basically, which gives me my core information. That sets up, kind of gives us the intro into the design session that we hold with them. So I'd say have a look at what I've got on TechNet Gallery. If there's still, I might still have some things beyond that, and happy to provide that if you send me a mail.
Great. Thanks, Brian. A few more questions and comments here. Again, the comments are great. Thanking you for a wonderful presentation. Christopher says he has some questions related to Linux discovery and health, and will we be covering this topic later?
Yeah, there is a Linux session, right?
Yes, there is. There's a Linux session. Okay.
Yeah, so there's a Linux session. I'll default to those guys. I'm going to admit right up front that I am not a Linux expert by any means. A small anecdote, which is kind of fun. I was actually at a training. I did a 5-day training in Europe a couple years ago, and it's kind of whenever I have a Linux person in the room, I usually know because I always know the Linux person because they always, it's just a different set of questions you hear. And it's always interesting to me because it's not an area I'm an expert in. But what was interesting is he had a little bit of a look here, I want to see some stuff about Linux. He had a very specific requirement. And it really goes back to my conversation on kind of classes and how these models and concepts are just so consistent in MPs. Basically, he gave me, there was some query we had to run. I apologize. I think it was a bash script that we did. And my apologies to Linux people if I completely butcher the terminology. But we were able to go out, pull out a module, some of the Linux modules that I had never used before. Just basic logic. Look, okay, here's the script we need to run. Here's the information we were looking for. First try, we had it working. So again, every concept I talked about, even though I didn't talk specifically about Linux, every single one of those concepts still applies. So hopefully they'll cover that in the next session on Linux. I'm sure that's going to be a much bigger expert than me. It is a hole right now in my MVA training. I need to get a Linux session in there, obviously. So that's something that I want to do.
Thanks, Brian. That's great. Yes, Jonathan from Infront will be doing his Linux session at 10:45 today.
Yeah, and Jonathan knows this stuff well, so I'm sure he's going to answer that stuff quite well.
Thank you for your attempt. Sounded like a great answer nonetheless. We've got a couple of minutes. We can go through some of the other questions. What would be a good approach for the monitoring of the client experience for, let's say, a network share, any sample MP? Sorry, that's from Simon. What would be a good approach for the monitoring of the client experience?
Yeah, so like a client, yeah, and client monitoring is just something that, I mean, it's something we kind of did a little bit earlier on. We used to do a bit more. I definitely have a little bit of client experience in my sample MP. I mean, it's really the same concepts. We don't have many samples out on that just because it's, when you look at the licensing model and how people typically use SCOM, it's a lot more on the server side that they do it. But usually a client experience, you're looking at probably what I think you're asking, is you're looking more perspectives. Can a client connect to a network share, for example? Let's run a script on a periodic basis, try to make that connection. If you don't see, let's see what sort of error comes back, and let's expose that a particular error code, right? So it's that kind of, we may have a server kind of acting as a client, and I think we're starting to get into perspective type monitoring when we do that. So apologies if that didn't totally answer the question. I mean, you're welcome to send me a mail and ask me a little bit more specific if I completely missed that.